So let's get started here with number 4, and let's recognize that in each of these parts here we are going to be considering these as our x values, and each one of these x values is going to create a second point, a point besides the given point, so that we can now calculate a slope or direction with the 2 points. And notice that 0 is some distance from point 5. The second point we're given is much closer to point 5. The third point that we're given is very, very close. And the fourth point we're given is, you might say, ridiculously close. Notice that we're coming from the left. We're starting with point 5, then point 4, point 49, and then point 499, almost to point 5 itself. Then we're going to continue, and we'll go and slip to the other side, the right side of point P, and we're going to start with an x of 1 on the curve, and then come much closer to point 6, and then much closer, 0.51, and then you might say ridiculously close, almost right on top of 0.5. So let's see how we can utilize technology to help us with this. So let's bring out the calculator and think how we might get it to assist us in this task, because right now we're looking at 8 separate calculations, and that's very tedious. I know one of them is a big deal, but to do it 8 times just seems like a lot. So let's bring up the calculator. Now, first thing we want to do is go over to the y equals button, and we want to enter the formula for our curve. So in this case, it's the cosine of the quantity pi, and use the pi key, which is just over the division sign. Have to hit the gold key first. The cosine of pi x. And let's put in another equation, and this is going to be our slope or direction calculation. And this is going to be our change in y over our change in x. Notice that we have one point that's given, and the second point we're going to calculate each time, and that's what y sub 1 is about. And let's start with a parenthesis and realize that our y is above in y sub 1. So let's hit let's hit vars, y vars, function, and y sub 1. So that's our calculated y. Our given y is 0. I don't even need to include it, but I will for the sake of completeness. That's our 0 that goes with point P. So that's our change in y, and we're going to divide by our change in x. Well, the x is whatever x we include, and we're going to subtract from that our given x, which is 0.5. So that's our change in y over our change in x. And for these problems, you can just leave formula 2 in there and keep changing out formula 1. Now, we need to set our table, and press your second key and your table set. And you want to make just one change here. You want the table to ask you for values. In other words, we don't want to put values in automatically. And our dependent value, we want it to calculate automatically. So make one change here, highlight the ask next to independent. And once you make this change, you don't have to come back here unless we have a different application where you want to change the independent to auto, for example. Once that's done, we're going to go to the table. And to get to the table, you're going to press second and table. And notice the table is completely blank. And we have a series of x's that we're going to enter. So the calculator is asking us for an x. We're going to give it an x. And then it's going to come back automatically with some values. The first one, recall, is our cosine calculation, our cosine of 0. And indeed, the cosine of 0 is 1. And the second calculation is our slope calculation. And so now we're going to have in the numerator, let me maybe write those values down here. In the numerator, we've got the change in y over the change in x for our slope. And that's going to equal, well, we did it with the cosine of 0 now is 1 minus the given 0 for the point. And we're going to divide that by the x value. The change in x was 0. And we're going to subtract the given x, the 0.5. So this calculation will be 1 over negative 1/2, which is, if you flip that denominator, flip that fraction, right, and multiply by the numerator, which is a negative 2. So on our calculator, that's where it's coming from. Now, let's put in 0.4. Let's put in 0.49. That's number Roman numeral 3. Let's put in 0.499. We could even take it a step further. The calculator doesn't mind. We could get a point even closer to 0.5. But the minute we put in 0.5, we're going to get an error, because remember, in our calculation, it was our calculated y. And let me just go back here a moment to capture that idea. Remember, we took our calculated y, which was y sub 1, which was this formula, and we subtracted 0, and in the denominator we said x minus 0.5. These were the coordinates of the point P. So if I put 0.5 in the calculator, it immediately objects, because now it has a 0 denominator and it says you can't do that, so it presents us with that error message. Now, I might point out to you that the furthest column on the right is our slope column, this column over here, y sub 2 is our slope column. And it looks like the last two answers are the same, but if we go over and visit, you get much more precision. It's not rounded. And notice that there is a difference between the one above and the one below. And maybe you have an idea about what that number is looking like. Negative 3.1415. And these slopes on the left, starting with negative 2 and coming to negative pi, fancy what's happening here. You know, when we have that first point there at 0, and we have our given point P, the slope of that line is negative 2. But if I do this again, and maybe I change colors on the line here just to distinguish it a little bit. Oh, let's make it blue. If I come and grab that point that is right next door, you know, to point P, that point that's at, to bring the calculator back and look at our calculation, that point that's at 0.499, we begin to see that that calculation for the cosine gets very small, 0.00314, and the slope with that point is approaching negative pi. And the rest of the problem is doing it from the other direction. So we can continue down in the table and put in these other values. And I'm starting now with putting in 1. And you see what happens there. And I guess I can't put any more in than what shows in the display. So let's maybe clear the display. I guess it doesn't want to clear. We'll just put in values. 1.6, 0.51, 0.501. We could get even closer. 0.5001, even 0.5001, right? Get, you know, as close as you want. But the minute I put in 0.5, I'm going to get that error message. And the point here is, no matter which direction you approach from, the secant is getting closer and closer to negative pi. And so we'll record all those answers in a grid, right? And answer the questions. So here I am back again with filling in a table with all these various values of x. Using the calculator to make all those calculations in the middle row and visiting those cells in the table to get them to 6 places as they asked. Remember, that's y sub 1 in the table. And then the slope calculation also coming from the table. On the calculator it's called y sub 2, but we entered a little formula in there to get it, and it produced all those values. And at the bottom in the gray, there's pi copied from the pi.org page, piday.org, excuse me. They have pi carried out to 1,000,000 places. Well, we don't have room for 1,000,000 places, so there's pi to about 200 places, and you can see that we're approaching negative pi as x gets closer and closer to 0.5. Part D of this problem asks us to sketch some secant lines, and that's not easy to do. I've got some drawn on there. The blue one is the tangent line, or my attempt at the tangent line, just touching at the single point at 0.50. The red one, pretty clear. That one's going through, well, actually going through 2 points. It's going through that point at 0, 1, and will go through at the point 1, -1. It is the one that has the slope of -2, as illustrated over in the last column. And then I drew in that green one just between there, when x is maybe about 0.1, just to see that it fell between the red and the blue. And of course, as the points get closer and closer, the secant line starts looking an awful lot like the tangent line, the blue line. So enough said about number 4. Hope this video helped.